Alright, in this lesson we are going to talk about how you can use pointers to work with variables that contain more than 1 byte of data. Recall in the last lesson that we added 1 to our pointer in order to cause it to point to the next data element in memory. The reason we could add 1 is because we were working with characters that were each 1 byte in size. So since each character was 1 byte in size, the next character would always be 1 higher in terms of memory position. So if we stored a string of text at position, let's say 8, and the string of text was ABC123, then the memory address 8 would correspond to the A, and then 9 to the B, and so on. But let's imagine we have this code. So in this example, we are creating 2 variables that each have a size that, for the sake of this lesson, we are going to assume is 2 bytes. This is because each of these variables are of the data type unsigned short int, which we are assuming is 2 bytes in size, although this can be different. So again, that's just for the sake of this lesson. Now let's consider how this set of variables are actually stored in memory. Let's suppose that the first variable, height, is stored at the memory address 8. Then it would look like this if we assume 2 bytes in size. And because we have created a pointer called PTR and given it the address of height, that means PTR is going to effectively contain 8, which is the memory address for height. Now keep in mind that because our variable is 2 bytes in size, it will take up 2 bytes in RAM. Therefore, this is not entirely accurate, because what I'm showing here are 2 bytes stored at a single memory address. What would actually be the case is that you would have the first byte at position 8, and then the second byte at position 9. Notice that this is simply the second byte of our height variable. Now let's go ahead and add the second variable, width, to our RAM directly after height. How would that look? I'll show you. Now take a look at this. At memory position 8, we have a byte full of all zeros. Remember, in this case, the unsigned short int is 2 bytes in size, and since these are such small values, the first byte is going to be all zeros. And that byte is basically the first half of height, and it is also where we are pointing the pointer PTR. In other words, PTR contains this memory address. So right now, PTR contains the memory address 8. At position 9 in memory, we have the second half of height, and then immediately after that in memory, we have our next variable, which is width, which is also an unsigned short int. So the first byte is all zeros because it's such a small value of 14, and then the second byte will contain the enough data to be the value 14, which of course is 2 and 4 and 8. Now, do not think, based on this example, that variables are always placed one right after the other in RAM when you create them. That's just for the sake of this lesson. Now that we know that PTR is pointing to the memory address 8, it might appear that star PTR would be equal to this. After all, that is the data that is located at memory position 8. That is not the case, however. Let's go back briefly to the lesson where we talked about how to create a pointer. I mentioned that it is important to specify the data type for what the pointer will be pointing to. In that lesson, I explained that asking for the data at a memory address is not enough. You have to also specify how much data you are looking for. In this case, I am not using PTR to point at 1 byte of data. I'm using it to point at 2 bytes of data. Therefore, star PTR will actually be this. The whole 16 bits that make up the variable height. Why? Because when we created the pointer, star PTR, we specified that it will be used for pointing at variables that are of the data type unsigned short int. So what would happen if we were to set star PTR to be equal to 0? Remember, right now it's set to 10. What happens if we set it to 0? If we do that, then C understands that because PTR was created to look at 2 bytes, then star PTR equals 0 would set both bytes to 0, so that the combined 16 bits would be 0. In other words, it will go through all 16 bits and set the final value to 0. If I was to write star PTR equals 5, then it would go through those 16 bits and set the value to 5. In other words, it knows that we want 2 bytes. How does it know that? Because we're using the data type unsigned short int, which is in this case 2 bytes in size. So let's expand on that a bit. Take a look at this code. Just going to format that a little better. Okay. So here we have created the integer height and given it the value of 10. Now let's assume that the memory address 8 is where height is stored. Here we're creating a pointer called PTR and setting it to the memory address of height. And then we set what is at that memory address to 0. If we do that, the final result will look like this at memory position 8. Notice that PTR will still be pointing exactly where it was before. Even though we've changed all 16 bits, PTR still contains what it used to contain. When I change star PTR, I'm not changing PTR itself. I'm not changing the memory address. It's still going to be what it was. So even though I've changed effectively 2 bytes, I haven't changed the memory address that PTR is pointing to. So think of this line of code, star PTR equals 0. Think of that as saying, store the unsigned short int value of 0. That means, in fact, this, into the memory location at position 8 in RAM. So since it's going to be storing 16 bits, that means it needs to change 2 bytes in order to do that. Now, one correction here is make sure that we're working with unsigned short int. Again, the data type is very important. So there you go. So you can see that star PTR will see and change 2 bytes of data which begin at whatever memory address is stored in PTR. Now consider if we want to change the value of width, the other variable we had, Let's just create that again here. Let's just set it to 5. What if we wanted to change the value of width to, let's say, 10? Based on the last lesson, we should be able to point our pointer to the memory address of width, which is 2 greater than the memory address of height in this example. Would we then say, for example, PTR equals PTR plus 2? No, because C understands that we have created a pointer for the data type unsigned short int. It knows that if we increment our pointer by 1, C will understand that we are incrementing an unsigned short int by 1, and it will therefore point to the next unsigned short int in memory, not the next byte in memory. In other words, this means that we want to cause PTR to point at the next 2 bytes in memory, and C will assume that those next 2 bytes are an unsigned short int. If that was confusing, here's what I want you to understand. At any memory address, whether it's 8 or 9 or 2 billion or whatever the case is, at that memory address there is a byte. Let's just say at memory address 8 there is a byte. Every memory address has a byte. I can set a pointer to any memory address. I can set, for example, let's say a pointer to memory address 1000. At that memory address there is 1 byte, but at the very next memory address there is also a byte. At the memory address after that, there is also a byte, which means that any memory address can be thought of as containing 1 byte, and also any memory address can be thought of as containing 2 bytes. In other words, I could say that this is an unsigned short int. If I say that this is an unsigned short int, then I'm looking at this byte and this byte. So if I set a pointer to point at this location in RAM, and this pointer is of the data type unsigned short int, then C understands that I have a pointer that is designed to be looking at 2 bytes. If I write the code PTR equals PTR plus 1, what C will understand that I'm saying is, okay, I'm looking at this unsigned short int. I want to be looking at the next unsigned short int. Let's just, and remember, the memory just keeps on going. So it would just keep on going. So if I write PTR equals PTR plus 1, what I'm doing is I'm moving this pointer to where the next unsigned short int would begin. Now remember, it doesn't matter what is actually located at these different bytes. And it might be, it could be anything at all in memory. For example, let's just create a random binary sequence to help illustrate this point. Okay. Imagine that we have a pointer, any pointer. Ignore this code for right now, and imagine that we have a pointer that's pointing to this specific memory address, and that this pointer was created as an unsigned short int. This is all of our code right now. We're just imagining this. We create a pointer called unsigned short int star PTR, so the pointer's name is PTR, and it's pointing somewhere in memory. We're going to assume it's pointing here. Then that means C understands star PTR is going to correspond to this byte, immediately followed by this byte, being a total of 16 bits. This is what star PTR means. If we change star PTR, for For example, if I set star PTR to, let's say, the value of 5, then C understands I want to change this entire thing to 5. Whoops. To 5. Which means it will go here, it will find where PTR is pointing, and it will change this entire sequence of 2 bytes to 5. That, what you just saw, is the effect of writing this. Now what if I write this? PTR equals PTR plus 1. Remember, it doesn't matter what is at the memory address in terms of the data type. Whether we're looking at characters or integers or whatever kind of data we're looking at, binary is binary. When we write PTR equals PTR plus 1, what C cares about is the data type that we used for our pointer. It's going to look at that data type. It's going to say, okay, this pointer was created as an unsigned short int. That means that this pointer is being designed to look at the binary sequences as if they were unsigned short integers. Whatever that data actually happens to be is irrelevant. It's just a binary sequence, and therefore it is whatever we tell C that we want it to be. In this case, we're saying we're treating it as an unsigned short integer. So when we write this code, PTR equals PTR plus 1, C is going to look at our pointer, look at the fact that it's pointing at 2 bytes, and then it's going to understand that we want to be looking at the next unsigned short integer. And it's going to be assuming that we're considering whatever is here in memory as unsigned short integers, regardless of whatever it actually happened to be before we used it. So when we have written this line of code, we have now changed PTR so that instead of pointing here, it is pointing here, which is effectively one unsigned short int forward in RAM. In this case, 2 bytes forward in RAM. Now if we change that, if we write star PTR equals 10, what we are saying is we are changing what is at this memory address, treated as an unsigned short int, to 10. Now that means 2 bytes. So C is going to go here and it's going to change this, and then it is going to go here, and lastly here. And that is exactly what would have happened in RAM. Whatever the 1s and 0s used to be is irrelevant. We're treating it as an unsigned short int, so that's what it becomes. So that is why the data type of the pointer is very important, because it allows you to specify how much RAM you are looking at or manipulating at a time. And it allows you to specify when you add to the pointer how many bytes forward in RAM you're actually going to go. So remember that because C understands we have created a pointer for the data type unsigned short int, C knows that if we increment our pointer by 1, in fact, if we do any mathematical operation at all on our pointer, that we are doing so on the understanding that each element we point to is an unsigned short int. This means that C realizes that if we say PTR equals PTR plus 1, like we do here, this means that we want to cause PTR to point at the next unsigned short int in memory, not the next byte in memory. In other words, this means that we want to cause PTR to point at the next 2 bytes in memory, and C will assume that those next 2 bytes are an unsigned short int. In our last lesson, because we were using the data type char, our pointer understood that we would be looking at data that was 1 byte in size. That is why adding 1 to the PTR in the last lesson resulted in the pointer address increasing by 1 byte. In this example, because we are using the data type unsigned short int, our pointer understands that we will be looking at data that is 2 bytes in size. That is why adding 1 to PTR in this lesson resulted in the pointer address increasing by 2 bytes. This same reasoning holds true for any data type. So let's go back and look at this code. Now here I have changed the code slightly. We're not using unsigned short int, we're just using int, which means the actual size is not going to be 2 bytes, it's probably going to be 4 bytes, but it depends on your compiler. Now, it doesn't matter because C will still increment the right number of bytes because it understands what we're trying to do. So here, first of all, we create an integer called height, we set it to 10, we create an integer called width, we set it to 5, we create our pointer, and we point our pointer to the memory address of height, which in our example contains the memory address 8. Again, we're just imagining that we have 16 bytes of RAM, just so it's easier to understand this. And we are also assuming, for the sake of this lesson, that width follows in memory immediately after height. That's just for the sake of this lesson, just so that this is easier to understand. So if that were true, when we write PTR equals PTR plus 1, we are effectively now changing the pointer so that instead of pointing at height, it will point at width. So again, if memory address if this memory address is set up like this, let's just, for the sake of this lesson, assume that this is 2 bytes in size. Again, it's not going to be 2 bytes in size because we're saying integer, but just for the sake of this lesson, assume that it is, because it's easier to understand that way. So effectively, when you set PTR to the memory address of height, you're setting it here, and height being set to 10 is basically this. And then if immediately following in RAM we had the next variable, which is width, this is what it would look like, and pointer would be pointing here. As soon as we write PTR equals PTR plus 1, then pointer will move to the next data type of that, the next data of that data type. Now let's assume that int is 4 bytes. How does this change? I'll show you. If int is 4 bytes instead of 2, then what happens is this. Okay, take a look. This whole thing is height. If we assume that integer is 4 bytes in size, this is 4 bytes. So PTR would be pointing here. With this line of code, PTR would be pointing here. And all 4 of these bytes altogether make up height. So you can see that height can actually be a rather large number because there's 32 bits. However, we're only using the last 4 bits of that, so you can see that's not very efficient, but I want you to understand what's going on here. Now I can immediately tell that our 16 bytes is probably not going to be enough, so let's just increase this slightly so that I can expand. So all I've done here is I've put a 0 in front so that when we fill up these bits, I have an extra bit for more memory addresses. So here, now the next memory address is going to be here, then here. Oh, it looks like I have just enough room. Okay, fine. Then for the sake of simplicity, let's undo that. All right. So let's imagine that this is height, where height is stored, these 4 bytes. So let's imagine this is width. Well, again, it's going to be 3 empty bytes because our value is so small, and then here 5 because we set width to 5. Now again, I'm assuming in this lesson that height and width are located in memory at exactly the same point. This is not necessarily true, just again, it's for the sake of this lesson. So here, if I change PTR to be PTR plus 1, what I'm doing is I am moving PTR to here. How does C know that I want to move it 4 bytes? It knows that because of the data type. So if the data type matches, it will move it the right amount. What if the data type doesn't match? Let's look at that. Let's suppose we created the wrong type of pointer. Now, remember, C doesn't care what the actual binary is. It's going to say, okay, you want an unsigned short int? That's 2 bytes. That's here. So in this case, star PTR will be just 0 because it's 2 bytes full of 0. That's what star PTR will mean. If I increment PTR, if I add 1 to it, and it's an unsigned short int, then C will say, okay, you have an unsigned short int, that's 2 bytes, so you want to be pointing here now. Now, star PTR will refer to this, which would be these 2 bytes here. That's why the data type is so important. You have to specify the right data type in order to move the right number of bytes when you change a pointer by, for example, adding 1 to it. So as long as the data type matches, you'll be fine. So what happens if, in this example, we want to change height to, let's say, 14? Well, what we would do is we would just write star PTR equals 14. Now what we've done is we have changed what is at the memory address PTR, which is height, to 14. Now if width was in memory immediately after height, we could change width by doing this. We could say PTR equals PTR plus 1. Now we have effectively moved the pointer to where width would be. And then we can say star PTR equals 14, for example, and change width to 14. Again, that's just for the sake of this lesson. I want to stress this again. Just because we created these 2 variables on 2 different lines right on top of each other does not mean that they're going to be located immediately after each other in memory. It's just for the sake of this lesson. Our 16-byte RAM is special because variables always get stored one after the other. In your real RAM, this is not always the case. So this code should not be considered something that you would actually write. It's just for illustrative purposes so you can understand how pointers work. Later on, I'll show you how to actually do this correctly. So if we look at the final state of RAM after we've let's say there. After this program, we set height to 10, we set width to 5, then we set the pointer to the address of height, and of course that means that star PTR is 10. Writing this code means to set it to 10, but it's already 10, so that's not going to do anything. Then we increment the pointer by 1, which is trying to move the pointer to width. And then we set star PTR equals 14. The final result will look like this. Height, and again we're assuming for the sake of this example, an unsigned short int. Or we're assuming that integers are 2 bytes in size. Your choice. But for this example, we're assuming that these integers each occupy 2 bytes, just so you can understand the way pointer iteration works. So our pointer is first of all going to point here, which is set to the value of 10. These 2 bytes are set to the value of 10. Then when we write this code, ptr equals ptr plus 1, we're going to move the pointer to point to the next variable, in this case width. And then with this line of code here, we are saying what is at that memory address is now getting set to 14, which means that C is going to look at both of these bytes and change it to 14. So in the next lessons, we'll look at this in more detail, including how to actually do this. What I want you to understand from this lesson is simply that when you change a pointer, for example, you write ptr equals pointer plus 1, let's say, ptr equals ptr plus 1, how many bytes in memory the pointer will move depends on the data type of the pointer. So for example, if we started with, let's say that ptr started with the memory address 8, and let's just write out some bytes real quick. Let's suppose at memory address 8 we have this, at memory address 9, I'm just kind of doing a random sequence of 1s and 0s. And let's stop there. Because remember, C doesn't care what the actual binary sequence is. So if we assume that ptr contains this memory address, and then we write this line of code, then is ptr going to move 1 byte, 2 bytes, or more? The answer depends on 2 things. First of all, it depends on what is the data type that the pointer is used for. For example, if it is a char, then it will move 1 byte. Always, characters are 1 byte in size. So when you say char, you mean 1 byte. If we were to write unsigned short int, then depending on the compiler, it would move 2 bytes. If we were to write int, then depending on the compiler, it would move 4 bytes, and so on. So the number of bytes that it's going to move depends on 1, the data type, and 2, the compiler. Different C compilers have different sizes for different data types. Integer could mean 4 bytes, could mean more than that. So it depends on the compiler. So you should never assume that if you write unsigned short int that it will always be 2 bytes in size. It depends on the compiler. And I'll show you more about this later, including how to actually see what the correct size is. So in the last lesson I showed you that you can increment a pointer, and by doing so you can look at the next memory address. We were looking at characters. In this lesson I've shown you that when you increment a pointer, you do so according to the data type. So therefore you will move the pointer a certain number of bytes depending on the data type. We'll go over this more later. Don't worry if you're a bit confused right now. We will cover this in a lot more detail.